So guys, as you can see, these are the two buttons here. This is the increment and this is the decrement speed of delays. So guys, as you can see that these LEDs are at, right now the code has started, so they are by default at 0 delay, because we have given 0 delay in the programming by default. So now I will press the increment button. It will increase the blinking speed. Oh sorry, it will decrease the blinking speed, or it will start blinking. At this time it is at faster 0 delay, no delay at all. Now we increase the delay time. So I press the button, see the delay value has increased. Now I press it further, it has more increased, more increased. I press it, it will keep on increasing. I will release it wherever it seems fine. Now see, I release it here. Now this value will remain like this until you do not restart the code. See that the value is same. It will remain like this. I further increase the delay, blinking delay. See, it is getting even longer and longer. See, I release it. Now it will remain like this forever. Now I will decrease the blinking delay. Now the speed of toggling will increase. I press the right button. See, I hold it. See, again it is getting faster and faster. See that. Now it's even faster. Now it's getting very fast. See that. Now that's it will remain like this. If you leave the button, the value will not change until you do not press the button. Now this delay will remain here. Now again I increase the blinking delay. So guys, hello guys, welcome to learning microcontrollers. In this video, I'm going to show you how you can interface a PIC16F877A microcontroller with an LED to blink it, and then we will use two push buttons to control the blinking speed. One button will increase the speed, another button will decrease the speed at the same time without reprogramming. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. Now guys, these are the three LEDs I'm going to use. You can use the one LED as well. I'm using three LEDs just for adding the beauty to the project. Now guys, as you can see, each LED has two pins, one longer, one shorter. I label them as the longer pin as the power and shorter pin as the ground. You common the ground of all three LEDs, then you send it to the common ground of your PIC16F877A microcontroller like this. Then guys, for the longer pin, you will need a 220 ohm resistor for each LED. So we are going to need three 220 ohm resistor for three LEDs. Now guys, let's start from the bottom LED. You connect the power pin to the one end of the 220 ohm resistor like this. Then from the other end of the 220 ohm resistor, you can use any digital input output pin of your pick. I'm going to use a pin number B4 for the bottommost LED. Then guys, for the second last LED, center LED, connect the power pin to the one end of the 220 ohm resistor like this. Then from the other end of the 220 ohm resistor, you can connect to any digital input output pin. I'm going to use the pin number B5 like this. Then guys, for the topmost LED, again do the same. Connect the power pin to the one end of the 220 ohm resistor like this. Then from the other end of the 220 ohm resistor, you can connect it to any available digital input output pin. I'm going to use a pin number B6 of the PIC, that is pin number 39 like this. Now guys, our LEDs are connected. Let's get to the buttons. These are the two push buttons. As you can see, each push button has two pins. You can shuffle these two pins, doesn't matter because it's not a polar component. Now guys, let's do its wiring. So let me label the left pin as VCC for each button, and the right pin of the top button as increment, and right pin of the bottom button as a decrement. So the top button, when it will be pressed, it will increase the blinking speed, and the bottom button, when it will be pressed, it will decrease the blinking speed. So guys, first of all, to connect these buttons with the PIC, you will need a 10 kilo ohm resistor each, two 10 kilo ohm resistor for two buttons, one for each. Now guys, for the top button, let's start doing the wiring. You will connect the increment pin to the one end of the 10 kilo ohm resistor like this. Then from the same increment pin, you will take your output out. You can use any available digital input output pin for the output. I am going to use a pin number C.F0, pin number C0, that is pin number 15 of the PIC16F877A. Now from the other end of this 10 kilo ohm resistor, you will send it to the common ground like this. Now guys, for the VCC pins, you just common them for both the buttons, and then you send it to the common VCC pin of the PIC like this. Now guys, for the bottom button, that is the decrement button, you connect the decrement pin to the one end of the 10 kilo ohm resistor like this. Then from the same pin, you will take your output out. You can use any available digital input output pin. I'm going to use the pin number 16 of the PIC, that is pin number C1 like this. Now from the other end of the 10 kilo ohm resistor connected to the decrement pin, you will take your ground pin out like this. Just common it with the ground. In this way our circuit is completed. So let me now introduce you to the hardware. So guys, this is our hardware here. These are the 3 LEDs. I'm going to use these 3. And then guys, these are the buttons. The bottom one, the center one is our, you can call it the increment button, and this right one is the decrement button. So guys, and this is our PIC16F877A, and this at the back is a PIC 3.5. So let's get to the micro C for PIC to do the programming. Let me zoom in. So guys, I'm going to use the version 7.2.0. The higher version 7.5.0 is also available, and if you have even higher version, that's even better. Go to the file, new project. This window pops up, new project wizard. Click on next, write the name of the project. I write increment, decrement, blink, learning, microcontrollers as the name of the project. Then PIC16F877A is the one I'm going to use here, and 20 megahertz is the crystal I'm going to use. I click on next and finish. Then this window will pop up. Press Ctrl S before doing anything else to save your project. Now before doing anything else, in the void main, declare the LED pins as output. Trace B equals to 0 cross 0 0. Just in case of Arduino, you use pin mode, command pin mode output. Here in case of PIC, you use the trace register. So 0 means output, 1 means input. So I had declared the whole port B as output because I have nothing else on the port B. So all the pins output is no issue. Now for the initial state, port B equals to 0 cross 0 0. This means 0 means low, that LEDs or the pins of the port B must be low by default, that initially. Like in case of Arduino, you write digital write low or high. So here we will use this command. Now give some initialization delay. I give 20 millisecond as initialization delay. Now guys, for the buttons, we have 2 buttons. One at trace C.F0 pin number 15 equals to 1. So see the difference. For the output pin, you use the 0. For the input, you use the 1. So 1 means input, 0 means output. Now give the initial state to the button. Port C.F0 equals to 0. Why 0? Because our resistor with the button is connected at the grounding end. If the resistor is at the grounding end, this means that whenever the button is pressed, a 1 will be sent to the PIC. So initially the pin must be at 0. So whenever the 1 comes, so we know the difference. That is, it was 0, now it has become 1. So like this is our increment button. I write increment. Now for the decrement button, just copy this. And decrement button is at pin number F1, C.F1, that is pin number 16. Only this will be the difference, and just change the command to decrement. Now we have our 2 buttons initialized and the LEDs initialized. Now we go to our forever loop, write down while 1, forever loop starts here, ends here. One thing is clear, that our LED is gonna blink. So this is the initial state of our LED. I make it like opposite, that now it's gonna blink. Now for how long it's gonna blink, we will need a delay here. So I write like delay start for how long and delay end. That for how long the LED must be on. Here we have to write a delay usually, but in our case we cannot write a delay because we have to like control the blinking speed with buttons. So then the LEDs will turn off. For how long they will turn on, there will be a code needed here. Something have to be done. We cannot use a delay command because we cannot, like I use delay ms20. That's good, but I cannot use an integer here. Like I want to write here, I use an integer called turn. So I give turn equal to 25. Now I want this turn to be just part of the delay command here. Now I build this, you will see it will give an error. So that's the problem. So we cannot use a delay here. That's clear now. Make turn equal to 0. Now you take another variable. We will need 2 variables. Let me show you the trick. Turn equals to button, the value coming from the button. Now also make the button equal to 0 by default, like this. Now guys, the point is we use a do while loop here, right? Do, and then close it while turn is less than button. Just repeat the loop until turn do not get greater than button, and turn will increase plus 1, turn equal to turn plus 1 with every repetition of this do while loop here. And as soon as the turn becomes less than the button, and button value will be sent here by our pressing. Whenever we press a button value will be sent. Now give some delay here. This will act as a, you can say, a unit. Like if you want the button, one press of a button, like if you hold the button, only one value at a time will increase for how long you hold the button. But if you make it 10, then 10 will increase. It will be very fast increase in the delay, blinking delay. And then after this has been accomplished, then the turn must become 0. So the next delay, this delay can come into play. So just copy it. This is the command here. You can make a function out of it. You can use it in different programs. That will be of great use, like this. Now guys, the next thing is we need the buttons to give the value to this button. This button variable will get values from our button. For that purpose, what we are going to do is that we will write if for the increment button port C dot F0. It's at port C dot F0. Just take this. If port C dot F0 double equal to 1. This means if the button is pressed, then give some debouncing delay. 10 will do fine. 10 millisecond. Again do the same. Just copy paste this here like this. Now give the ending brackets like this. If button, that is our increment button, is C dot F0 at pin 15, then button, this variable, just copy it, equals to button plus 1. So if the that is button at pin number 15 is pressed, then the button variable will increase, this value will increase, and this value is here, and this value will increase, and turn will take a longer time to reach this value. Like it will need more loops, more delay. It will add more delay, so it will increase the blinking speed. Now for the decrement button, just copy this and just make it, because decrement button is a pin number C dot F1 like this, and for the decrement we will need a minus here like this. Rest will remain the same. Now we just build the code like this. We build the code. The code is built. I click on write. Okay, here we go. Let's select the code we just made. So this is the code. I click on write. Okay, the new code is being written. Let's get to the hardware. So this pin is connected to basically pin number B6. B6 is pin number 39, and this is a programming pin. So it's just blinking because of programming. So let me power up the PIC from here. So see that the blinking is very fast. Now I press the increment button, so it will increase the blinking speed. See, I pressed it. Okay, let's get back to the coding. We made some mistake. Okay, we made a terrible mistake here. It must be port C. Sorry, we copied the wrong command. It is port C dot F0, not C dot F0. Port C dot F0. It is also port. We just copy pasted. Trace is only for declaration purpose. I copied the wrong command. So port C dot F1. Now build this code. Write it. So we have this is basically, this one was to be copied. I accidentally copied this one. So port C dot F0, port C dot F1. Let me zoom out. Let's get to the hardware. Now see that the delay is at minimum. I increment this because we started from 0. See that the initial value was 0. See the delay is increasing. With the I keep it pressed, delay will keep on increasing. See that still the increment button is pressed. You can see that the blink is getting longer and longer. See that it's still pressed. It's still longer and longer. Now see the blinking speed has greatly decreased. Now I hold it further. The increment button, see the blinking speed is still decreasing. See that now it's longer delays between every blink. See, I stop it, again I keep it pressed. Now I decrease the blinking delay. I go for the other button, decrement button. Now see that blinking speed is increasing. It is triggering at faster speed. For as long as you hold the button, it will keep on increasing. See that See, it has become very fast now. Okay, now this speed you can also control from here. I zoom in. See that I told you this delay here is important. Now to increase the triggering speed, you can do two things. Either you can increase this or you can also increase this value as well. So I increase this value, I make it 10. I do the same here, I make it 10 like this. Now it will increase at even a greater speed. No, just make it 1, make it 1. This is the multiplication factor, I make it 10. Now with every push of a button, it will be multiplied by 10. With every push of a button, it will be multiplied by 10. So I build this code and write it. Let's see now, after pressing the button, the speed will be increased by a different value. Okay, I increase the, see, now the delays are immediately causing the change in blinking speed. See, every loop is getting longer now because we are having 10 millisecond delay. See that? See, now it's longer value. I press it further. See that it's even getting longer. See, now it immediately, because now the speed has increased 10 times for changing the blinking speed. Now I decrement it. See, it will immediately get faster. I hold this. See, it is getting faster and faster. See that? So now it's very fast. Now again I increase the blinking delay like this. Now there is another way you can play with this code. I will give you this code in the description of this video. There will be a Google Drive link. There will be this code. Now you can also play with this button speed as well. This one. This you make it 10. It will also cause the speed to increase at a faster pace. Also make it 10. Now increment and decrement speed both are same. If you want to change the increment decrement speed, simply change these values. Okay, let's make it 1 again. I make these delays 1. This delay inside the loops like this, and I only increase these speeds. I make it 20 like. Now whenever the buttons press, it will be like 20 times faster speed like this. I build the code and now I burn it. I click on write. Okay, the new code is being burned. That is basically pin number 39, programming pin as well. So it is during programming it blinks. Okay, now see, it starts at 0, no delay at all. Now I press this, it will immediately, see, with just tick of a button, it is, see, because we are having a very high increment factor, see, now it has immediately increased the speed. See, it has immediately added the delay like this. You can see that I leave the button. Now it will remain at this space, It will not change value until the button is not pressed. So you can set the value of the blinking speed like this by pressing the button only. See, now I further press this. See, it is getting longer and longer. Now I decrease this delay time. See, I press the other button. It will again go faster. See, with every second it is getting faster. See, now it's faster. I hold it for another second. See, it is again getting faster. Now wherever I leave it, it will remain at that speed. I again decrement the blinking speed. See, now it's very fast. So guys, this is it. This is how you control the triggering blinking speed using push buttons. So you can play with the code. There is a lot of things you can do with this code. You can make functions out of it. So guys, if you have any questions or queries, you can ask in the comment. I will share the all of these micro C files in the Google Drive link in the description of this video, so you can download it from there. So thank you very much for your time and patience, and have a nice day.